Good morning, and thank you for joining our webinar discussing flow measurement with thermal mass technology. My name is Jim Haldeman. I'll be your host. I'm the Business Development Manager for Process Instrumentation at the Lessman Instrument Company. We are joined this morning by Ray Young, Sales Manager at the Thermal Instrument Company. Ray's career began at Thermal Instrument Company when he was in college as a calibration technician. And Ray then graduated from Drexel University with a bachelor degree in operations management. He then went on to work in the manufacturing and logistics and operations division for over 20 years at a Fortune 500 company. And then he recently returned back to Thermal Instrument Company as the Director of Sales and Marketing. So we'll begin the presentation shortly. I just want to mention that you can enter any questions you may have in the chat box as questions, and then they'll come to me, and then I will ask them to Ray, or you can just hold until the end, and then we shall ask those questions at the same time with Ray. So what I'm going to do now is I'm going to change the presenter to Ray. And Ray, you can then begin the presentation.
Okay, thank you, Jim. Thanks everyone for jumping on here today. Appreciate your time. And what I'd like to do today is just kind of give you an overview, and I appreciate Jim's introduction there. So he saved me some a little bit of conversation pieces here. But just kind of jumping into a little bit of Thermal Instrument. Thermal Instrument has been a company that has been around since 1959. We are a family-run business. We're located outside of Philadelphia, PA. We are one of those companies that truly did start in the basement of a house, and we've grown from there up to a 10,000 square foot facility where we do the majority of our calibration work, some assembly work, and so on in producing some of our thermal mass flow meters. What's a little bit different about thermal mass flow and Thermal Instrument and how we handle that is we're more of a custom solutions provider. So just kind of keep that in mind. We don't have hundreds and hundreds of these units sitting on the shelf ready to go. Every unit is kind of crafted to your unique application. So we can do a lot of things to help fit into your applications. So just kind of keep that in mind as we go through. My goal is to tell you a little bit about how thermal mass works, maybe some of the benefits that you will see by using thermal mass, and then where it could possibly fit into your processes and help you measure some of your flow applications, and how some of our units and some of our different designs will help you do that. Because one of the things that you will see is that just looking at the screen right now, our designs are pretty diverse. We offer insertion probes for large line size. We offer sanitary units to connect in for food, beverage, and even some other clean applications like clean gases for either pharmaceutical or even like semiconductor. So we can get into a lot of different things here. So we can hopefully help you out with something as we go through this presentation. Maybe you'll see something that you'll hopefully find useful and that you can go back to your Lessman sales rep and follow up with them on. So jumping into the presentation, let's talk about a little bit about how thermal mass works and what thermal mass is doing. So for one thing, Thermal Instrument only does thermal mass technology. We don't offer any other types of measurement technology. Thermal mass measures the mass of a fluid in a line, and that fluid can be a gas or a liquid. So that's one differentiator that Thermal Instrument can provide, is that we can measure both because we have calibration stands that are set up for both liquids and gases. We use basically a two-sensor approach with backup sensors that are ready to go if necessary. We have one sensor that measures the fluid temp, and then it sets the temperature of a second sensor, being the flow sensor that you can see in the picture here. It sets that second sensor to a predetermined and constant temperature above that of the fluid passing by. So basically, as we tie a voltage to that sensor, and as more fluid goes through that unit, we actually have to increase the voltage to maintain that constant temperature differential. So basically at no flow, there isn't much voltage or current needed to keep that sensor, maybe 50 degrees above that of the fluid that's sitting in the line. But as flow increases, it's going to require more energy or more voltage to that sensor to maintain that differential, because as fluid comes through, it's going to basically pull heat away from that sensor that's being warmed up. And then we correlate basically that voltage back to a flow rate. And then we output that across a 4 to 20 or several other outputs that we can offer to you. So it's a very tried and true system. It's a very repeatable system. So you'll see that as we go through in some of the benefits. And I guess the easiest way maybe for me to give you kind of an analogy, if you think about heat and heat transfer, if you're driving in your car and you're sitting at a stoplight and you put your arm out the window, well, you're not very cool. But as you start to move down the road and your arm is hanging out the window, you'll notice that you start to get cool very quickly. The faster you go, the more cool you feel, because it's pulling heat away from your body. So it's kind of the same principle. So what we're doing is we're just maintaining that constant temperature differential so that we can correlate that voltage that it takes to back to that flow rate. So the other nice thing that I'd like to point out here that's a little bit different about how we do something here at Thermal Instrument versus maybe some of the other thermal mass providers out there is that you'll notice that there are redundant sensors on this picture that I've put in here. The redundant sensors are calibrated and ready to go at a moment's notice. In the event that maybe your operation has a power surge, we've had units outside where a lightning strike has been close by. These redundant backup sensors are there and ready to go, which offers you as the customer a pretty good return on your investment, because we've had units out in the field that have gone out into the field in the 1990s and are still being used today. They may be on their backup sensor, they may not be on their backup sensor, but the fact is that they're still there, they're still working, and they help provide very long life to our units. So let's talk a little bit about now some of the benefits of using thermal mass flow. For one thing, thermal mass flow is very accurate. Typically, we're plus or minus 1% of full scale in most situations. The reason we could be accurate is our sensors really never come into direct contact with the fluid, and typically cannot be fouled by any foreign substances, where it would degrade the sensitivity of that sensor. So we can give you some very accurate measurements for many years. And that goes back to some of our design, which we're going to get into here in just a little bit. The other thing about thermal mass flow is it's very repeatable. Typically our units are plus or minus 0.2% repeatable back to the original calibration that you would be provided. So thermal mass is a very accurate and repeatable instrument that can be used for measuring gases or liquids. The other nice thing about thermal mass is the wide turn down. Turn down typically means how wide of a flow range can you see. If you've got a flow range that's, for example, 0 to 100 SCFM or 0 to 100 GPM of water or SCM of air, we pretty much with our units can show you, in most cases, we can show you 1 SCFM, and at the same time, we can show you 100 SCFM. We can measure both ends of that spectrum. Some other technologies may not be able to do that. So that's why it's good to talk with your salesperson and know your application and know what you need to see and what you need to measure for your application. The other benefit of thermal mass is that we're temperature compensated. So temperature changes are not really a problem for us. As long as we know where you're operating, where your mins and where your maxes are, we set all that up during calibration. The other nice advantage of using thermal mass is that typically pressure is not a problem for using thermal mass. Thermal mass is very good in low pressure, and it's very good in even vacuum environments. We really don't care so much about pressure from a measurement perspective, because as long as that fluid is passing by the sensor, whether it's being pushed or whether it's being pulled, as long as it's going past, it's still taking heat away from that sensor. And that's how we're, that's how we're doing that measurement. So there are a lot of other technologies out there where pressure is very key to the overall effectiveness of that instrument. Whereas in our instrument, pressure really doesn't come into play. Where we take pressure into play is more on the safety aspect. We want to make sure that we give you the right process connection. So if you're going to be running at a high pressure, we want to make sure that we give you something that will hold up and connect into your line so that you don't have anything going on there that could be a safety issue.
Ray, we have one question regarding the flow direction. So if you're pulling a vacuum, what does the display show? Does it show a negative or does it show a positive?
No, it's going to show a positive. So as long as it's going past it, it's going to show a positive. Our display will never show a negative.
Okay, thank you.
And then the last one of the other benefits here to thermal mass flow is that we can provide basically a flow measurement output as well as a temperature output, because we've already got the sensors in place. You just need to tell us when we're going through the process of setting these units up and talking through about your application, what you need to do. So you basically could be saving yourself some costs on buying a second unit because we can give you a temperature output that you could use in your process. A couple other benefits to thermal mass is that typically thermal mass is very flexible. And especially in our environment here at Thermal Instrument Company, we make some very small units. We can get down to small line sizes as small as 1/4-inch OD tubing. We also make units that can handle very large ducts and chimneys. So we have units that, such as our insertion probe that you see on this page, that we can utilize. So, depending on the line size, thermal mass can be a very effective solution that way. We have numerous process connections, which we're going to see as we go through here. There's no moving parts, so you don't ever have to worry about anything really kind of clogging up or jamming. And the response time on thermal mass is pretty good. We're typically about a ½ second for fluids, and about 1 second on gases. So liquids about ½ second and gases about 1 second for the meter to see a change and report that change out. So, and then we've already talked about some of the low flow velocities where thermal mass, because of that wide turn down, can see at the low end of your flow range as well as at the high end of the flow range. So those are some of the benefits of using thermal mass. One of the things I'd like to do here is just want to point out, now this is where some of our unique designs at Thermal Instrument Company may be able to help you, because when we design our thermal instrument flow meters, we have two different styles. We have our inline style, which basically means we're delivering an unobstructed inline flow meter that basically is just an extension of your existing piping. Our sensors, as you can see, looking at this top picture, there's nothing in the tube, nothing in the pipe. Our sensors are actually behind an inner outer wall. So they're mounted just like in that first slide. So they never come into direct contact. So that gives them nice long life. The other nice benefit about looking at our units is you can see that because there's nothing inside the tube, as long as we are mating up to your process piping, you're going to see very negligible pressure loss, which is great if you've got pumps or different things downstream of this. You don't want to see any pressure drop going through a flow meter. So that's an advantage. That's one of the advantages of being unobstructed. And then, the other nice thing about our units is you'll see a variety of connections here. We've got welded ends here. We have tri-clamp, there's flange. We can give you threaded ends with like VCO, VCR. We can give you NPT pipe, tube ends, you see it. We've done a lot of different process connections, so we can fit in with a lot of different piping applications. We also can do some protective coatings on these units. So that's advantageous if you've got maybe something that's a little corrosive going through there. We can work with you to come up with the right protective coating, as you can see in one of the photos here. And then last but not least, we will use a number of different materials as well. So our standard is 316 stainless steel on a lot of our units, but we can build out of Hastelloy C, we can build out of titanium, tantalum, and we do these on a regular basis where we go out and we get some special metals to hold up to special conditions. So again, this goes back to the comment where I said we're a little bit more diverse, and we will work with you to come up with a solution to help you, properly measure your application. So this is just one style of meter that we offer, and this is our inline meter. The second type of meter that we offer is our insertion probe. And the insertion probe, we have kind of a unique design. We call it our single piece design. And the reason we have the single piece design is that it can be used in both liquid measurement and in gas measurement. And as you can see, there's nothing on this design here that could clog up, or a port that can be fouled, or whatever the case may be. And even on this picture here, you can see that I'm showing one that's coated. So this is typically where our sensors are located, down here in the bottom part of our probe. And what we've done is we've applied a Teflon coating in this case, and we do this for many different clients that maybe have a dirty environment. Maybe they have a little bit of moisture in there that they need to run that, so that we run that moisture or that dirt away from the sensor area to keep it free and clear for many years to go. The second design that we have is our dual tip design. Our dual tip design is typically used in higher temperature applications. It also can be used where you've got a wide flow range, and we need sensitivity to both a very low end or maybe an extreme high end of flow. So it's a very good solution in those types of environments. The nice thing about using our insertion probes is that, like I said, we can do liquid and gas. So both of these units will work. We work with you to determine what the conditions are, and then we will recommend the right one. We also can customize a lot of these units. So we can make them different lengths. We can make them different ODs in order to hold up to different conditions. So if you need a flange connection, as shown over here, we can do that. If you've got a large line size and maybe you've got some turbulent flow conditions because you might not have, maybe you've got some bends or different things in your piping creating some turbulence in there, we can put multiple sensing points as shown on this unit right here, where we can take flow at different points going across the line. So this is, so again, the insertion probe is very customizable, material-wise, just like it says here, process connection-wise, coatings, you name it, we've kind of done it, and we can build these to suit a wide variety of flow applications. So now let's get into a little bit about how you maybe want to, what you need to know about getting an accurate measurement using thermal mass. First off, it's really important to know that you've got the right technology, because some technology is better than other technologies when it comes to measurement and what you're trying to measure. So it's definitely talking with your salesperson and then getting on the phone with us if need be. We can help make sure that we're giving you the right thing for the right application. It's also important to make sure that you know your conditions. Know what your temperature ranges are, know what your pressures are, know what your flow rates are, know where you need to measure down to, what you need to measure up to. Those are all good things. Other things to keep in mind is that, where is the meter going to be situated? Do you have a straight run before and after the meter? because in any measurement environment in any instrument typically will require some straight run before it and after it so that you get a good flow profile going past the meter sensors. So you can see what we list here. We typically require 10 piping diameters upstream of the meter placement and 5 after the meter placement without any changes. But the one thing that we can do that maybe some other people can't do is that if you don't have that, what we can do is we can maybe customize our calibration stand to simulate what you do have. So we might need a little bit of information from you as far as, some dimensions and things like that. But again, that's where Thermal Instrument kind of differentiates itself from some of the other players out there. And one of the things that, one of the things I want to stress here is that, we will simulate a lot of different environments and, we will work with you before the sale and even after the sale to make sure that we support you through that process. So, so if you don't have that straight run, don't worry. We just need to know what you do have so that we can, work through that with you. Something else just to point out, when we send you a quotation, I kind of put just a snippet of a drawing here, but this kind of shows the facts of the different one of the different process connections that's available to you. And this would be our hot tap, and this is just on our insertion probe. So what this hot tap allows you to do is basically if your process is running and you need to remove the unit for any reason, you can open this, you can close this valve after you pull the unit up through the port. You can close the valve off and keep your process running. So I just wanted to show that as we were on this page, but you can see how the units are used. These are actual photos from field shots out there, used indoors, they're used outdoors, they're used in clean environments like this up here. This is a pharmaceutical application. So, and then they're used outside on pipelines and different flue stacks and everywhere that basically you can imagine liquids or gases running through a piping system. Let's talk a little bit about measurement capabilities. For one thing, with our units, because I've mentioned we can measure liquid and gas, you can see the wide ranges that we can cover. We can go anywhere from 1 to 10 feet per second on liquid measurements. Some liquids are better than other liquids, so all these are application dependent. It all goes back to how much heat transfer and the thermal properties of that liquid. So for example, water is a great fluid or liquid for taking away heat, but maybe a number 2 fuel oil is not going to take away as much heat. So every application is different. And what we can measure, but we will be upfront with you and we will tell you what we can do. On the gas side, we have a very wide range, anywhere from 30 to 85,000 standard feet per minute. So again, thermal mass could be a good solution for you, if you're falling into any of these numbers. Response time, like I already mentioned, is fairly quick. Low flow rates, this goes back to our ability to downsize our units. So we can deliver units as small as 1/4 inch OD in order to see some very low flow rates. And as you can see, as stated there. With regards to viscosity, when you're talking about fluids going past our flow meter instruments, we've measured things as thick as peanut butter and chocolate. Not at the same time. We weren't making Hershey's Reese's peanut butter cups, but we have measured things like that. So again, thermal mass, as long as it takes heat away, it could be a possible solution for you. We've done some extreme pressure ranges. Typically, when we're getting into the higher pressures, we're typically dealing with smaller line sizes. Typically 1/4 inch, 3/8 inch when you're talking about 4,000 or 5,000 PSI, just because that's we have to build the unit to withstand that pressure as well. So, but again, just to let you know. And then temperatures, as you can see, anywhere from -100 degrees to 500 F. We typically cap our calibrations at 500 degrees F just because we don't have the capability to go much above that. at our facility here in the Philadelphia area. So, but if you've got an application that you're maybe a little bit above that, let's talk. We might be able to do something to help you out there. So, and all these numbers are really application dependent. So, but just wanted to give you a nice general idea. Now that we've basically shown you the different styles and the different types of units that we can offer and how we can fit into your piping arrangements or your plumbing arrangements, the important part is how do you get that information back to where you can use it. So we offer a variety of transmitters. We have an integral transmitter, which is our 9500P, which is this guy down here. It's mounted right to an insertion probe in this photo. But this 9500P can also be delivered as a remote, like is pictured up here in the top right-hand corner. So in a remote environment, maybe you've got a pipe that's running along the ceiling or it's running high, or this measurement needs to be taken high in the chimney stack. The nice thing about the remote is that you can put the sensor where it needs to go, and then with up to 1,000 feet of cable, you can drop the actual transmitter unit down to some place where a operator can read it, can reset a totalizer, can check connections, so on and so forth. All of our units deliver a 4 to 20 milliamp output. They can be we can accommodate RS-45 Modbus. We can do pulse outputs. We can do HART outputs on the 9500P. And we also on the 9500P offer a 2-line display like you see here. Some of our other transmitters are 9200B, which is this guy up here. This is more of a panel mount. Typically we find these in control rooms where the sensors are out in the production area and then they're run back to this control room and are used there. And then last but not least is our 926 remote electronics. And this is kind of an older style electronics, but some of the things that we can do with this, it gives us the ability to not only deliver a flow output back to your control center, to your PLC, to whatever it's going to via the 4 to 20, but it can also do some bidirectional indication. So if you've got a condition where your flow might reverse and you need to know when it reverses, this unit here can trip a relay to let you know based on a sensor in the flow element going off that your flow is reversed. Or we can also do some things like additional alarm relays. We can do some dual ranges. So if you've got a flow rate that runs really low 90% of the time, but maybe 10% of the time you have a chance for an upset condition where the flow might go up maybe 500%, we can range this so that you know when that happens and measure to within reason some of those things. So all of our electronics can be powered by either 110 or 220 VAC or a 24 volt power source. So the one thing I do want to stress here is that with thermal mass, and this is pretty much true with all thermal mass, all units are a 4-wire device unit. We are not loop powered. Because we are heating up a sensor, we actually need to power the unit. So that means we need 4 wires, 2 wires to power the unit and heat the sensors up, and then the other 2 wires will power that 4 to 20 loop to bring that information back to your control room or PLC. So just want to state that because that's one of the questions typically I get a lot is, oh, I'm looking for a loop powered device and 2 wires. Well, in our situation, you will need that 4 wires. Now that you've kind of seen a little bit about some of our designs and where we possibly could fit in, where are we used and where could we be used maybe in your application? So thermal mass is used all over the place. We're used in numerous power generation facilities across the US. We've delivered thousands of units over the years for measuring things like oils, natural gas in the boilers, furnaces, kilns, you name it, we've got a unit probably on it. We've done an extreme amount of compressed air, CO2 gas for bottling, clean gases in semiconductor, clean gases in pharmaceutical applications, clean waters for food and beverage. You name it, we've kind of done it over the years. So, so one of the things about thermal mass and going back to the experience of Thermal Instrument Company, that we've been in business since 1959, we've seen a lot, we've done a lot. Our technicians have been in the field a lot. So hopefully, our experience can help you kind of manage through your measurement applications here.
Ray, we have one question regarding
Sure.
water. Does there need to be a level of conductivity like you would need in a mag meter for thermal mass measurement?
Actually, that's one of the advantages of using thermal mass. Thermal mass doesn't care about conductivity. We just care about the thermal transfer, the heat. So whether it's DI water, regular water, water for injection, we don't need conductivity like a mag meter does. So where mag meters have some advantages in other areas, that's where we have an advantage in that we don't need that conductivity. We definitely could be considered if you've got an application where you have a deionized water or something that doesn't have conductivity.
Thank you.
Sure. I wanted to show you some of the things that we do on a regular basis, and where maybe we can help you out. So we do a lot of measurement of different gases. We do methane, we do natural gas, lots of hydrocarbon mixes. We do tons of landfill, bio, digester gases. So all these gases are basically very unique mixes: flare gases, flue gases, different types of propane. Anywhere where you might have to measure something that you may have to report is something to consider thermal mass for, because all these gases are being used on a regular basis or being emitted on a regular basis. And the other nice thing is, because we're used to doing a lot of these gases, we can actually do some custom gas calibration mixes. So if you've got a different mix, say you've got 40% methane and 25% propane, we can actually do a custom calibration to make that work. You just have to tell us what that percentage is, up to 100%, and we will calculate that out with our engineer and come up with a calibration that works so that when the unit arrives at your location, it's ready to go right outside of the box. Other gases that we measure on a regular basis, like I mentioned, we do a lot of airflow measurement. We do a lot of hydrogen, nitrogen, helium, oxygen, you name it. We're doing these on a regular basis. And some people, well, you're measuring air. Well, everybody can measure air, and it's like, yes, but we're measuring air in lots of different environments, whether it be food and beverage, where they're maybe using a heated air and need a clean instrument to do that, or a pharmaceutical, or maybe you want to find out about what department is using your compressed air. So these are all different applications and why thermal mass could be effective and could be used in these things. And then the other nice thing that I like to point out too is that, when you're working with a company, you want to make sure that you're working with a company that will actually calibrate on that specific fluid. So when you're working with hydrogen, for example, hydrogen does not have a correction factor that is consistent. So what does that mean? It means that basically, if you're working with someone, you want to make sure that they're calibrating on hydrogen, because if they're going to calibrate on air and try to convert it to hydrogen, you're not going to find an accurate unit, because there is no consistent factor that can be applied from 0 all the way up to maybe 100% of that flow range. The factor is going to change. So that's why it's best to work with a company that's used to working and doing the calibrations on the fluids that you are working with. Other gases that we do on a regular basis, we do a lot of carbon dioxide, a lot of chlorine, a lot of argon for steel manufacturing. Chlorine is used in lots of different applications as byproducts or maybe as the initial product. And then you can see various different gas mixes. So just wanted to point out all the different things that we've measured over the years. And if you're not seeing something that you are doing, you know, work with us, work with your salesperson, and we will let you know if we've done it, because we've done numerous mixes and numerous gases over the years.
We have a couple questions.
Yeah, sure.
One is only have half full pipe. So I think what they're asking is, do you need a full pipe to make a measurement?
Yes, typically we do, because of where our sensors are positioned, whether it's an inline unit or a insertion probe. If you've got a liquid if you've got a liquid measurement that you're doing and it's not always full, and if it doesn't touch the sensor, if you've only got half a pipe and maybe it's just below that sensor point, well, the sensor is going to tell you, no, you don't have anything in there, you don't have any flow. Whereas if it's just below, you are going to really be having flow. You're just not going to see it on the instrument. So it's best to position the instrument. If you know you're going to have times where the lines may not be full, maybe you want to position it in a well or someplace like that where the line would always be full, even at low flow rates. So there's ways around that, but yes, we typically need full lines.
Thank you. And in his example, he stated he had a 60-inch pipe in wastewater, and it doesn't always stay full, and so that's just a little more elaboration. But I think that the answer to the question is optimally yes. You need to have a full pipe.
Yes, that would be, because the calibration again is going to be calculated on a full pipe. So.
Yeah.
So even if we, let's say in a 60-inch pipe, if we put the insertion probe through the bottom of the pipe where the fluid was sitting, if it's only half full, the insertion probe is still going to read it like it's full. So
right. So essentially, you wouldn't have. Yeah, you wouldn't have. I mean, it might because the calculation is based on a full pipe ID, and if it's half full, it still sees the flow, but your calculations are going to be off by 50% for that period.
Correct.
Got it.
Correct.
Okay. And then the other question that was asked is, what about nuclear energy or radioactive fluids?
Now, typically, we're not doing radioactive fluid. We are in many nuclear facilities, but what we're typically doing in there is we're doing either hydrogen for cooling, we're doing air, we're doing nitrogen, we're doing CO2 in power generation, we're doing some flue gases, and we're even doing the #2 fuel oils that are maybe running some of the motors and different things in there. And the cooling water is another example of things that we've done in power generation and nuclear power. But we typically have not been in radioactive fluids. One of the things that we can do though is our one electronics is actually approved. It's EMI conditioned, and that's our 926 electronics, which is actually one of the reasons why we've kept it in use so long, because that is one of the electronics that actually has been approved by several power companies and has been used by several power companies in areas where radiation might be an issue.
Thank you. If you have any additional questions on that, please feel free to ask, and then I'll relay those to Ray. Go ahead, Ray.
Okay. And that was a perfect lead in, because the next thing I wanted to talk about was some of the liquids that we've done over the years. So we just talked about cooling water. We've talked about DI water, water for injection. Again, getting back to the statement, we don't need conductivity. So thermal mass is a good option for you if you don't have conductivity, because we only care about the heat transfer and the thermal properties. You can see some of these other fluids here, like #2 fuel oil, solvents, ammonia. Different fluids have different thermal properties. So as I stated earlier, we can measure up to about 10 feet per second from a velocity standpoint. Some fluids like water, yes, 10 feet per second is very doable, but maybe a thicker fluid or a fluid like a #2 fuel oil, we're maybe talking 7 feet per second using our technology. And that just comes down to the, basically at a certain point, it just stops taking heat away from our sensor. So the flow curve tends to flatten. So again, we will work with you with your fluids, and we will tell you what we can and can't do and where you can expect to see good results. But different fluids do have different thermal properties. The one thing I do want to elaborate on here, though, is if you've got a proprietary fluid, we will work with your fluid. So if you need to send us a gallon or 5 gallons or 55 gallons, we have signed NDAs on a regular basis. We receive your fluid, we calibrate the meters on your fluid, set up the meters on your fluid, and then we either return the fluid or get rid of the fluid. So those are things that we can do that maybe some other players out there aren't necessarily willing to do, is that we will actually work with your fluid. We're doing that right now. We've got a fluid in-house that we're testing for a bioengineering company. So they required us to sign an NDA. We did that, and now we're testing their fluid through our meters for overall performance. So that is something we're willing to do. So I'm getting here towards the end, and hopefully I've given you some information here that can help you through your processes. But kind of want to wrap it up with a couple questions here to really kind of pose these questions to you, because if you can answer yes to any of these questions, you might find that thermal mass is a good solution that you may want to consider and find out more about. So as I mentioned throughout earlier in the presentation, our units are used in a lot of places where our customers are reporting for regulatory purposes. Our units are used where flue gases or biogases or vents, anything that requires some sort of reporting where they have to tell whether it's the EPA or the local state, state agencies, what they're using and where they're using it. Thermal masks is something that could be used. If you want to know what departments are using the valuable, let's say you're purchasing large quantities of oxygen or nitrogen, and it's being, it's coming into your facility, or argon, very expensive gases. You want to know where it's being used, in what departments, compressed air, who's using it. That's where thermal mass can help you, because we do a lot of submetering applications. We've worked with research labs where, they need to know which lab project is using how much of the gas so that they can backfill it to that particular research project. So that's, something to keep in mind where thermal mass could be used. And then the other application.
We do have a question. I want to throw it in here.
Sure.
Someone's asking, how does the accuracy compare to a Coriolis type meter?
Okay, good question. So Coriolis is typically considered a custody transfer and a very accurate meter. Coriolis meters in some environments can measure, and I'm not a Coriolis expert, but I know that there's some of their stated accuracies are basically 0.1% of your flow full scale. We typically are 1% of your flow full scale. However, what you'll find by looking at our units and looking at a Coriolis, you've got to make that decision about, do you need 0.1% accuracy? And if you do, then Coriolis is probably the way to go. If you can live with 1% accuracy across your flow scale, and then are willing to maybe save a little bit of money, because typically a 1-inch inline unit for a Coriolis unit might be $5,500 to $6,000, whereas a thermal mass unit might be $3,000 or $3,500, depending on the application. So you've got to kind of do that justification. We've had customers in the past who have switched from Coriolis to thermal mass technology because they said we can live with 1% and save a couple $1,000s per unit. So, but Coriolis is a very good technology, but you just have to be prepared to typically, know that their cost of that technology is also something that you're going to have to contend with.
Thank you, Ray.
No problem. I guess the last question, really, if you can answer yes to, if you're really concerned, if you're seeing some discrepancies, maybe whether it's a bill from a gas supplier, a fluid supplier, or even just your utility supplier, you want to know where maybe your natural gas, are you really using that natural gas, or what portion of that natural gas is being used for the boiler versus other places in your operation. So, these are all things that, you should, that hopefully will help spark some ideas on where you maybe could be a little bit more efficient, and, where our meters maybe can give you that data that you can use to make, smart business operating decisions. So that's really all I have to present for you. So I'm hoping that I've answered some questions, or at least given you some ideas, and appreciate, I'll be sure to answer any other questions, but appreciate everybody's time here as well.
Thank you, Ray. That was very informative. I think it answered a lot of the questions I was hoping we would be able to discuss. I don't see any additional questions coming through at this time. I'm not going to open up the mic because that just turns into a feedback disaster. So I guess I would ask that if anyone on the line has additional questions after the fact or after the meeting, please feel free to reach out to your local Lessman rep. Of course, you can also reach out to me, Jim Haldeman, which is jimh@lessman.com. And of course, you can reach out directly to Ray and ask him any questions as well. So with that being said, if there's no additional questions or comments, I think we'll end the presentation. So thank you again, Ray, and I wish everyone,
all right, no problem.
I wish everyone a great and productive day.
All right, take care, everyone. Thank you for your time.
Thank you.